sample, that's going to translate into the temperature. So the more the particles are moving, the higher the temperature. So when they say the average kinetic energy, that's the average motion, because kinetic energy is energy of motion. And you'll often see kinetic energy abbreviated as KE. When you've got two objects touching, heat's going to transfer from one object to another, and it's always from the warmer object to the cooler object. And there are a few different temperature scales that we're going to be using in chemistry. So we will use Kelvin, Celsius, and Fahrenheit. And the historical significance of all of these is discussed within the reading. I will let you read that on your own time. I'm going to focus on just doing the conversions with you so that you understand how to do that. There is a separate rule for determining significant figures in temperature conversions. They talk about it here. We're not going to do that. Okay, I left it there in case you use your book as a reference later on in another class. So let's take a look at these conversions up here. So you've got two calculations up here at the top. The one on the left is for converting degrees Celsius into degrees Fahrenheit. The one on the right is for converting degrees Fahrenheit into degrees Celsius. And then down on the bottom, these are for Kelvin. Technically, there is no such thing as degrees Kelvin, so don't place a degree symbol in front of the K, okay? So here, if you're converting degrees Celsius into Kelvin, you would use this equation. And then if you're going to convert Kelvin into degrees Celsius, you would use this equation, okay? Let's take a look at the practice problems, the last set of practice problems that are on the next page, okay? So on the next page, we've got 3 practice problems, and I'm going to try and make it so that we've still got these equations next to us, so if we need them, we can reference them. Number 1 says cesium metal is really soft. It melts below body temperature. We're going to convert its melting point from 28.4 degrees Celsius into degrees Fahrenheit. So that means you're going to use this first equation here. So this is going to be 28.4 degrees C times 1.8, and then you're going to add 32. Usually I have you round to the nearest whole number. Just read the directions on the problem when you're doing a temperature conversion. This comes out to be 83.12. I'm going to write it as 83 degrees Fahrenheit. Okay. The next one tells us that air can be liquefied at negative 319 degrees Fahrenheit. They want us to convert it to degrees Celsius. In order to do that, you're going to use this second equation. Okay, so we're going to take negative 319 degrees Fahrenheit, subtract 32, and then divide it by 1.8. You should get negative 195 degrees C. And then number 3, they want us to convert absolute zero, which is 0 Kelvin, into degrees Fahrenheit. And they gave us a hint. They said convert to degrees Celsius first. That's because there is no direct conversion from Kelvin to degrees Fahrenheit. You have to convert Kelvin to degrees Celsius and then degrees Celsius to degrees Fahrenheit. You can see that from the equations that they gave us. So I'm going to convert Kelvin into degrees Celsius first. So this is a 2-step problem. Step number 1 is 0 Kelvin minus 273 is negative 273 degrees Celsius. And then step number 2 is going to be negative 273 degrees Celsius times 1.8. And then you're going to add 32. You're going to get negative 459.4. And that is your degrees Fahrenheit. You probably can't see that one very well. There you go, negative 459 degrees Fahrenheit. Okay, your homework is open. It is due Tuesday at 8 a.m. I'm going to give you the rest of class time to get started on it. I would recommend doing the work in the blank page. If you turn the pages, you're going to see chapter 1 notes. There's going to be a blank page in your book. I would recommend doing the work there, so that way when you ask me a question, we have work to look at to figure out where you went wrong. Okay?